This is video 8.5, slope-intercept form. Let's start by looking at the definition of slope-intercept form. Slope-intercept form is a linear equation in the form of y equals mx plus b. Now this is something we've already previously talked about. So it's the form y, so it's in terms of y, equals mx plus b. It's in slope-intercept form when it's in this form. The m represents the slope of the line, and the b represents the y-intercept. Now let's explore this a little bit further by looking at our example over here. All right? Here we have an equation that's in slope-intercept form. So it's y equals 2x plus 3. Okay, if we think about this as slope-intercept form, or y equals mx plus b, that would mean that 2 is our slope, and that 3 represents our y-intercept. Now let's explore a little bit about why this is so. If we look at our picture over here, our y-intercept is where our line crosses the y-axis. That's at 3, and you'll notice 3 is our y-intercept here in our equation. Another way to look at it as well is to think of it this way. If I were to substitute 0 for x in this equation, 2 times 0 would be 0, plus 3 would make 3, so y would equal 3. So when x is 0, y is 3. So it almost always has to be that number right here, where b is. So the y-intercept is 3. Now our slope is represented right here. It's a rise of 2 and a run of 1, or 2 over 1. And you look here, m is the slope, a rise over run. 2 over 1 is the same as 2, and we have our slope here in our equation. So this is what we call slope-intercept form. So let's practice this a little bit here. We want to identify the slope and the y-intercept of the line with the given equation. So here's our equation, y equals negative 1/3 x plus 6. So if we take our slope-intercept form, y equals mx plus b, that would mean that 6, which is b, is our y-intercept. And negative 1/3, which is in the place of m, would be our slope. So we have easily identified the slope and the y-intercept because our equation was in slope-intercept form. Now if I were to graph this would be really easy because I could find 6 on the y-axis, graph it, and then I would use the slope to find the next point on my line. I would have a graph. Now this one's a little unusual. You'll notice there's no plus anything here. Now I could assume it's going to be plus 0. Or I could also think of it this way. If I substitute 0 for x and multiply it by 3/4, then y is going to be 0. So I know that my slope is 3/4 because it's y equals mx plus b, and my y-intercept equals 0. Let's take this a little bit further and match our equations with our graphs here. Let's start with the first one here. Y equals mx plus b. All right, I know that my y-intercept for this particular equation is 2. So I want to look on my graphs to see where my graphs have the line crossing the y-intercept at 2. And I see that happens here, and I see that it also happens here. But you'll notice here, it's actually crossing at 1/2. So this cannot be this particular graph. But if I look here, number 8 has a y-intercept of 1/2. So number 8 is probably C. So let's go back to number 7. It could be either A or B. We're looking for a slope of 1/2. That means that I'm going to have a rise of 1 and a run of 2. So let's see if that's true. So if I go up 1 and over 2, this would be the next point on the line, which clearly isn't true of that line. Plus, if I look at this line, it's going up in the negative direction of the x-axis. So this is probably this is a negative slope, where this one's a positive slope because it's going up in the positive direction. Now if I look here and I go up 1 and over 2, notice that that is the next point on my line. It has a rise of 1 and a run of 2. So this would be number 7, B. And A has -2 as its slope. So that would be a rise of -2 and a run of 1. Well, a rise of -2 means go down 2 and over 1, and that works. So that means that this equation is A. Now let's look at this one here. Okay, if I look at this one, the 1/2 y-intercept is here, right? And it says it has a slope of 2. So that means I would go up 2 and over 1. So here would be my next point. So the slope works for this one, so we know this one's C. All right. Let's identify the slope and y-intercept of this line for the given equation and use the slope and y-intercept to graph our equation. So y equals mx plus b. That means that our slope equals 5/4, or a rise of 5 and a run of 4, and our y-intercept equals 1. So that means I'm going to graph my y at 1, because it's 0.01 is my y-intercept. Now I'm going to follow my slope. I'm going to rise 5, so 1, 2, 3, 4, 5, and I'm going to run 4, 1, 2, 3, 4, which gives me a point right here. And then I can graph this line. So now I've graphed the line for y equals 5/4 x plus 1 right here. Except it looks like my screen slid a little bit. Now let's talk about finding the slopes of parallel and perpendicular lines. All right, we know two lines are parallel when, if you look at these two lines here, when they don't cross. Okay, two parallel lines will never cross. And they also have to have the same slope. So if you look at line A, it has a slope of 2. It has a rise of 2 and a run of 1, which makes it a slope of 2. You'll notice the same thing with this one, a rise of 2 and a run of 1. So both of these have the same slope, which makes them parallel. And that's true of all parallel lines on a coordinate plane. Now, if you look at a perpendicular line, remember, a perpendicular line is when you have two lines that cross and form right angles. So line A, again here, has a slope of 2. I rise 2 and run 1. But the line perpendicular to it, line C, has a slope of -1/2. That's because perpendicular lines have slopes that are negative reciprocals of each other. Now let's look at what that means down here. Okay? This is an example of if my slope is m, then a slope of a line that's perpendicular would be -1/m. So let's apply this. For the line with a given equation, find the slope of a parallel line and the slope of a perpendicular line. Okay, let's go back to our y equals mx plus b. Okay, so we know that our slope is 6/5. So that means any line that is parallel to this line would also have a slope of 6/5. A line that's perpendicular would have to be the negative of this. Well, the negative, or the opposite of 6/5 is negative. And the reciprocal, which the reciprocal of 6/5 is 5/6. So our perpendicular line has a slope of -5/6. Let's look at this one. Now for number 17, it's a little bit different because it's not in slope-intercept form. So this equation isn't quite as useful in this form. So let's start by putting it in slope-intercept form. So I'm going to start by adding 4x to both sides of my equation, which will give me 4y equals 4x plus 16. Now it's not in slope-intercept form yet because I still have this 4 in front of my y. So I want to divide both sides by 4. Now be careful here, because remember, dividing by 4 is kind of like multiplying it by 1/4. So I really have to do this to both terms on this side of my equation. So over here I get y because the 4's cancel out. But here I end up with 4/4x plus 16/4. If I simplify this, I get y equals 1x plus 4. Now we're in y equals mx plus b form, and I can identify my parallel and perpendicular slope. Well, my slope is 1, or 1/1, so I'm going to write parallel. My parallel line slope would be 1. My perpendicular line would have to be the reciprocal. Well, the reciprocal of 1 is 1, and its opposite, so -1. So the perpendicular line would have a slope of -1, and the parallel line would have a slope of 1. Now it's your turn to try on the next few problems. Otherwise, this is the end of our video 8.5 slope intercept.